So today we will start with public versus private IP address. So before we left in yesterday's session, we have seen that how you will be looking after the IP addresses, your machine IP address, and then we have seen that actually the public IP address, how you will look. I haven't discussed much more things. So today we will discuss what is public IP address, what is private IP address. So yes, guys, as I told you yesterday, you need to keep your mics mute, please. So coming to the private IP address, we will first discuss about the private IP address. What is private IP address? See, these private IP addresses are the addresses, as I told you yesterday, that IP addresses are divided into two groups within the IPv4 address. They are divided into two groups depending upon your usage: private IP address and public IP address. Private IP addresses are used within your private network. Like, for example, you have your router at home. Let's say this is your router provided by your ISP. Your internet service provider has given you a router to which you connect to the internet. And then this router, you will be having multiple devices connected. Multiple devices. It can be your PC, it can be your printer, or it can be a mobile phone. So all these devices, whether it is a PC, printer, mobile phone, or you're connecting your laptop, whatever you're connecting to your network, home network, or even if you are in office, and all the devices, the PCs, servers, switches, all these networking devices, whichever are connecting, will be connecting to the private IP address. They will be connected to the private IP address. And these IP addresses, private IP addresses, cannot talk to the IP address which is over internet, that is public IP address. Now, what are the different type of private networks, public networks? That all we are going to discuss in the coming time. In some time, we'll discuss everything. But for now, just understand that all the devices which is connected to your LAN network, which is connected to your home devices, or the devices which are connected to your offices like PCs, servers, switches, all the internal devices, that will be having the private IP address. Meaning that this IP addresses, the machines which are having the private IP addresses, cannot talk to any devices over the internet. Now, let's say, for example, you have these servers. Let's say this is your google.com server, or let's say this is your facebook.com servers. These servers are over the internet. So if these machines, either it is a PC or mobile phone, if this PC or a mobile phone want to connect to any of the website which is over the internet, they cannot talk directly. Directly communication between this internal devices which has a private IP address cannot talk to the devices over here. But there is a mechanism where you can translate that. We will learn a different concept is there. But for now, just understand that the devices which is connected to your home network or to your office PCs that has a private IP address. The type of IP address is private. Another thing is public IP address. This public IP address is something which is assigned to the every devices that is directly accessible over internet. Now let's say if there is some website google.com. So this specific website which is accessible to all the public over the internet will be having the public IP address. And when you talk about this public IP address, this is unique. I mean, there cannot be two same public IP addresses. Now, but over here, when you talk about the private IP addresses, now let's say the PC might have the IP address. The PC might have the IP address 192.168.1.1 or 1.1.10, for example. The PC might have 192.168.1.10. Let's say there might be a friend house who is also accessing the internet, who has his own internet access from the ISP. At his home also there is an router, and at his home he has his laptop, he has his printer, so there is a possibility that this laptop also will have 192.168.1.10, because private IP addresses are not unique. Private IP addresses are used for the private network. So at your home you might have this IP scheme. There is a possibility that your friend house also might be using the same IP scheme. There is no uniqueness in the private IP address. Private IP addresses can be same at multiple places. But when you talk about the public IP address, so the IP address which google.com has, it doesn't necessarily, there is no possibility that the same IP address will be used by anywhere. No, that is not possible. These IP addresses are unique. So each public IP address is globally unique. No two devices on the internet can have the same public IP address at the same time. And the devices with a public IP address, the devices with a public IP address, like let's say for example, Google is one server, this is one device, then Facebook has its own server, it has its own device. Similarly, there will be Yahoo, which has its own server, own device. So devices with the public IP addresses can be accessed directly from anywhere in the internet. This google.com can be accessible from anywhere. Globally, if you want to access the google.com, you can access because it has a public IP address behind it. And this public IP address is the public IP, even on your router, this is your home router, right? So if you have taken a connection from the internet service provider, at that time you will realize that there will be one public IP address assigned to this router also. There will be one public IP address assigned to this router also. Now your router might have this IP address. Let's say 1.1.1.1. Your router will have this IP address 1.1.1.1, for example, assigned by the ISP. Your internet service provider will assign this IP address, which is public IP address. Now, when you connect to the internet through an ISP, when you connect to the internet, like let's say for example, this PC is that this PC wants to connect to the internet. It wants to talk to google.com, or it wants to talk to facebook.com. What this PC will do, this PC will send a request to router that I want to reach to google.com. But as I told you that this PC has a private IP address. So this private IP address cannot talk directly to google.com. So what will happen? This PC will send a request to the router that I want to talk to google.com, and then this router will translate this private IP address into public IP address. When it reaches over here, the PC request comes over here. It says that I want to talk to google.com. Then this router will translate 192.168.1.10, that is private IP, into public IP, and now this router will take the request of this on behalf of this PC to google.com using 1.1.1.1, because this private IP cannot talk to the internet directly. Is it clear? Any question, any doubts over here? Up to here, if there is any doubt, please ask me. Sohail says it is clear. What about others? Daniel is asking, how does the router have an ability to convert the address from private to public? So, Daniel, we have one topic, network address translation, NAT. In that, we will discuss how the router has the ability, how it converts. Everything we will discuss. Don't worry. If in the first or second lecture I will tell you all things, then the first lecture will become the last lecture. So everything will come. Don't worry. So the public IP address and private IP address is clear, right? So what is the difference? When you talk about the differences, public IP address is unique, whereas private IP addresses, sorry, public IP addresses are unique, private IP addresses are not unique. They can be used in multiple networks. Private IP addresses are not routable over internet. These IPs cannot directly talk to the internet. But these public IP addresses are routable and they can talk to each other. Private IP address is meant for local communication. Public IP address is meant for the communication over internet globally. Now let's talk about assigning the IP address. We have seen that we have been talking about the PC has this IP address, or printer has IP address, the server has IP address, router has IP address. We have been talking about this since long. Since yesterday, we have been discussing about the IP addressing. But now the questions come that how these IP addresses are assigned. How these IP addresses are assigned. So we will talk about IP address assignment. So there are two different types to assign an IP address to a device. There are two different methods. One is static, static method, and another method is dynamic. Anyone know the difference between static and dynamic? I am not asking anything related to CCNA. It's a simple English term. Anyone knows what is static, what is dynamic? Yes, that's right. Okay, you are right up to the mark. That static, it will be permanent. Dynamic will be something that will not be constant. It will be changing. That is right. Anyone else? Okay, I will. See, first of all, static IP addresses are the permanently assigned IP addresses to device. Static IP addresses. When you talk about static IP addresses, they are permanently assigned. They're permanently assigned IP addresses, and this is very important. The IP addresses are assigned permanently. This is very important when, when. I will tell you when. Now, assume this scenario, we have the website from google.com. So there is one IP assigned to this server for google.com, which is 2.2.2.2. Now assume that you have assigned dynamically. We have understood that dynamic is something which is not fixed in nature. It will keep on changing. Today, the Google server IP is 2.2.2.2. The user are able to connect properly. Everything is going fine. If tomorrow this IP is changed to some other IP, will this user be able to connect to this IP again, to this server again? Is the IP address is changed? No, that is something not possible if the IP address keeps on changing. Let me add you something. For now, we are saying that if the IP address is changed, then it is not possible. In today's world, it is possible. How it is possible, we will discuss later. But for now, just understand that it is not possible to connect. If the IP address of this server changes, then this PC will not be able to talk to this server. In the coming time, I will show you how it is possible. Everything will learn. But for now, understanding the basics, just say that when the IP address of this server changes to some other IP instead of 2.2.2.2, then this PC will not be able to talk to the server. That is the reason where we need a static IP addresses. The IP address which should be remaining permanently with this server. This IP address should not change. So this kind of setup, specifically static IP addresses, are something which are important for servers or the devices that need a constant address. So, reliable for static IP addresses are reliable for network services that require regular access, such as website, or let's say, for example, you have server known as FTP server, or you can say something like a remote management server, something like this. FTP stands for file transfer protocol. This server is basically used to transfer the file. If you want to transfer the files and all, you use FTP. We will discuss when we will discussing about different type of protocols. At that time, we will discuss about this as well. So if this is the case, the user, the PC 192.168.1.10 want to transfer a file, and let's say this server has IP 10.11.20.31, and tomorrow if this IP changes, if it is not a static IP, this user will not even come to know that what is this IP address and how he will be accessing the FTP and all. Right? Then comes a dynamic IP address. So dynamic IP address is something which is assigned temporarily, now let's say this is a router of your home router. This is your home router. You have PC, printers, mobile phone, everything is connected. And if you go to your PC or if you go to your mobile device, you will see that this IP address is something, assigned dynamically. You haven't assigned in your home. Is there anyone who has assigned the IP address for connecting the internet? Yes, anyone? You are using a mobile phone. Have you assigned the IP address to a mobile phone? And every we have learned yesterday that if you want to communicate over internet, IP address is a mandatory requirement. IP address is a home address, and without IP address, you cannot reach to anything over the internet. So, is there anyone, a smart guy in the class, who has assigned the IP address on this mobile phones, on their smartphones? Or if you are connected your laptop or a PC to your internet either through a Wi-Fi or through a LAN network, have you assigned the IP address? Yes, Daniel says that no. What about others? You are assigning the IP address. So how come this IP address come? This comes dynamically. And who does this? In your home, everyone has internet, right? If you have taken the internet from some of your local internet service provider, of course, Airtel, VSNL, or Reliance will not provide you internet at home because they are providing the enterprise network. They will be providing the internet access to the enterprise, like the companies which are organizations which are working. But for home, definitely, as far as I know, they are not providing the internet at home. Correct? So most probably it will be your local ISPs, small ISPs who are providing the internet. They, what they will do, they will be providing you with the router. One router will be there at your home. Everyone has seen the router, right? Or is there anyone who has not seen the router till now? The router at your home. So this router's job is to provide the IP address to this PC, printers, mobile phone. And for providing this IP address, assigning this IP addresses dynamically, the router uses DHCP protocol, and DHCP stands for Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol. What stands for? Dynamic Host Configuration Protocol. So, okay, for some reason it is not moving. I will write it again over here. This router does the job of assigning the IP addresses to your PCs, printers, mobile phones, which you are connecting at home network. And router does this job using DHCP, Dynamic Host Configuration Protocol. This is the protocol. Now, again and again, I'm talking about protocol. So, protocol is nothing but a set of rules that define how the communication will happen. We'll discuss when we will discuss about the protocol. But now we are discussing very basic concepts from the beginning. So, I will not go in detail about the protocols and all everything over here. So your home router uses DHCP, Dynamic Host Configuration Protocol, to assign the IP addresses to these PCs, printers, and these IP addresses are private in nature. Now, as we have learned that DHCP is used and dynamic IP addresses are provided from the pool which the router has. In the router, you will define that for my home network, I want to use over here on the home network, I want to use 192.168.1.0 network. This way, what is network? Till now, we are only discussing about IP. What is network? That we will discuss. But for now, you will say that uh, from 192.168.1.0 to 192.168 dot 1.100, use this IP addresses from this pool. Give the IP addresses to my PC or to my printer, whichever devices is connecting over my network. Give the IP addresses from this pool. So what will happen as soon as the first device connect over the internet, dynamically this router will give the IP 192.168.1.1. Dynamically this router will give the IP 1.2, 192.168.1.3, and so on. In this way, the IP addresses will be assigned to all these devices dynamically. And one more thing, when you talk about the public IP address, you have to pay for it. It is not free of cost. But when you talk about the private IP addresses, they are free of cost. You can use it as many as you can. And when you take the connection from the ISP will provide you one public IP address for communicating all your internal devices, whichever the internal devices, maybe 10, 50, 100, 1,000, whatever devices you have for which you have a private IP addresses, it will be the router will be having the gateway which through which you go outside, through which you reach to the internet, will be having one public IP address assigned by the ISP. It will be assigned by the ISP, and this IP address assigned by the ISP can either be static or it can be dynamic. At your home, when you take the internet connection, this IP address assigned by the ISP is dynamic. It is not static, it is dynamic. Is it clear? Any questions, any doubts till now? I can see very few are just responding. What about others? Please confirm in the chat box. Okay, let's move ahead with the discussion. Now, let's discuss another topic, which is how do IP address works. We have learned what is IP address. We have learned the types of IP address. It can be public or it can be private. Then we have seen, depending upon the usage, the IP address can be the IP address can be assigned statically or dynamically. And one more thing, the concept which I have shown, static, dynamic, that is not completely have shown. Only I have shown you the basic. More things are going to come, but at the right time. Now, how do IP address work? This we will be discussing now. Now, we have learned that every devices that connects to a network, whether it is a computer, smartphone, or a server, is assigned an IP address. Now, this is your assume that this is your PC, okay, and this PC is connected to your router. To the same router, there is one more PC connected. Let's say this is your PC1, this is your PC2. So as we have learned that each and every device will have some IP address. So PC1 has IP address 192.168.1.10. PC2 has IP address 192.168.1.20. We have learned that if PC1 wants to talk to PC2 over the network, it can talk using the IP address, which is similar to the home address. If you want to reach to a person home, you need to know the home address. In the digital world, it uses IP address. That is Internet Protocol address. Now the question comes, how this communication will happen from PC1 to PC2. So what is going to happen is this PC1 says hello to PC2. So this hello will not go completely as it is, but it will be divided into small, small parts. And there is something concept called frame. Small packets are formed, that is nothing but a frames. So when this PC1 says hello, so there is something, it will contain source IP. First of all, a packet is formed. Packet is nothing but a combination of multiple things. It will has source IP. Okay, it will has similar to you send a letter at someone's home. Now you have your own address. Then it will have a destination IP as well. It will has destination IP. That is the IP address of the PC2, and the actual message will be there. What is the message? That will be over here. That is data. That is called as data. In this way, the packet travels over the internet. What it contains? The sender address, that is source IP address, SIP, contains the address to whom it is sent, destination IP, and the data is there. In this way, basically, the communication happens. And this frame doesn't stops over here. As we go on learning the concepts, this frame will increase because the MAC addresses are going to come, the headers are going to come, uh, encapsulations are going to come. There are many things, but in short, the basically this is how it happens. Because we have only learned IP address, so we'll discuss only related to IP address for now. So the source IP address is added, the destination IP address is added, and the data which need to be sent is added, and it is sent as a frame like this over the internet. Is it clear how the data is sent? Is it clear? Now let's discuss about the NAT also. NAT, network address translation. And I'm recalling again that whatever I am showing you is just a basic touchline. I'm just preparing you for the advanced topic over here. So don't expect that everything will discuss today itself. These basic foundations we are preparing now, and as the time passes, we will be learning each and every concept in detail. So NAT, network address translation, as the name implies, the job of this functionality is to translate your addresses. As I told you that in your home network, the IP addresses which are assigned to you is through your home router, and that IP addresses are dynamic in nature, assigned by the DHCP of your router, that is dynamic host configuration protocol of your router. So this will be a private IP addresses. And at the same time, we have discussed that your ISP, your internet service provider, will be giving you one public IP address on the router. And this router public IP address will help you to talk to the internet servers. This we have discussed just some time before. So the router device which is over here has the NAT functionality. It has a NAT functionality. So NAT is basically a process where your multiple local IP addresses, like this is the PC IP address, this is the printer IP address, or even your mobile phone will have a IP address. All these IP addresses, multiple local IP addresses, will be mapped to this 1.1.1.1, that is public IP address. How it is added, we will be doing the lab. In that, we will learn how to map it, how the netting is done. But for now, just understand that how this happens. We have discussed that these private IP addresses, which are assigned by a router over a DSCP, cannot talk to the public IP addresses. The public IP addresses are the IP addresses of your public accessible server. That can be your website, it can be or any public domain like google.com, facebook.com, and anything. So we have discussed this. To talk to this, what we need, if this PC want to talk to google.com, then this PC must have the public IP address. Using this private IP address, this PC cannot talk to google.com. So what this PC does, it sends a request to the gateway, that is nothing but a router, and it says that I want to reach to google.com. Now do one thing, everyone open your command prompt. Everyone open your command prompt and type ipconfig. See, for me, this is the network. Everyone can see their IP address, right? Their private IP address, everyone can see. So you will see that over here you have IPv4 address. Everyone has IPv4 address. For me, it is 192.168.0.169. Then there is something called default gateway. There is something called default gateway. For me, it is 192.168.0.1. Everyone has a default gateway, and most of them will have the default gateway 192.168.1.1. Is that true? Most of them will have the default gateway 192.168.1.1. Is that true? Guys, are you there with me? Have you opened the command prompt and typed this command ipconfig? Okay, what is your IP addresses? Can you please put again? Like you did yesterday, na? Same way. Put the IP addresses in the chat box. Why I said that mostly will have 192.168.1.1, because everyone, not everyone, but most of them uses this IP scheme 192.168.1. something. So Daniel says that his IP address is 192.168.1.5, meaning most probably he will have the gateway, default gateway written as 192.168.1.1. What is this gateway? As the name implies, gateway is a gate, like your home has a gate. Similarly, over here, the computer devices, networking devices will also have a gate to move out and come in. So this gateway is the computer that if you want to reach anywhere, use this gate, use this IP address to move out. So what will happen? Similarly, this PC, which has an IP address 192.168.1.10, will have the gateway address as 192.168.1.1, which is nothing but the router LAN IP. Router LAN IP, which is 192.168.1. Which will be 192.168.1.1. So this PC wants to talk to Google. What it will do? It will send the traffic to gateway, which is nothing but the router LAN IP 192.168.1.1. And now let me write it over here. 192.168.1.1. Now If this PC wants to talk over the internet, it will send the request to the gateway, which is 192.168.1.1. And now, what is going to happen? Not only this, even if this printer is there, it will have the same gateway. Even if it is a mobile phone, it will have the same gateway, 192.168.1.1. So all of them will be sending the request to 192.168.1.1. And over here, there is some special configuration done. That is nothing but called as netting. We are doing a netting over here. We are saying it to the router that the request, whether it comes from this IP, any of the IP, we will define a pool saying that any request coming from 192.168.1.10 to 192.168.10.100, if any request come, translate this IP to your WAN IP address, which is 1.1.1.1. Translate this IP to this. Once it is translated, then the request will go to google.com, and google.com can understand 1.1.1.1 is a public IP address, it is routable over internet, and the communication will happen. Is it clear? Any questions over here? Now, let's explore it in a more better way. Consider this is my PC. Okay, this is my PC. It has IP address 192.168.1.10, and the gateway is 192.168.1.1, and I am connected to my home router, which has public IP address 1.1.1.1. Now, at your home, you have seen that your router, this is a router, right? And then this is your ISP network. This is your ISP network. Your ISP will be there. There will be lots of routers and all this, and how the network is, we will learn later. So you have an ISP network. There will be multiple routers over the internet. Everything will be there. And then let's say there is one more network somewhere running in the world, somewhere anywhere in the world. Okay, there is one more router. It may be your home router, for example, and it has the IP address 22.22.11.11, for example. And again, over here there is one PC or a server. Let's say there is a server, and it has IP address 192.168.20.11. Now, what is going to happen? This user, let's say, sitting over here in India, for example, wants to talk to this server, which may be hosted in USA. This PC1 has a private IP address, which is 192.168.1.10, private IP address. Now, and this IP address is provided by this router through a DSCP. Okay, and at the same time, over here we have a server which has the IP address 192.168.20.11 with the gateway 192.168.20.1. It is a gateway. Okay, this is the gateway of this server. Now, this server also has the private IP address assigned by this router or a DSCP. And this server has a gateway, which is the router port IP address, router interface IP address. This PC wants to talk to this server, or let's consider an example that this PC1 want to send an email to this server. Okay, this PC1 will write an email in their email box, and it will hit the button send. This request will pass. This request will pass over an internet. In this flow, it will go and it will reach till your server. Over here, what is going to happen? As soon as PC1 says send an email to this server, it hits the send button. This request from the PC1, which has IP address 192.168.1.10, will look for his where to send. This PC doesn't know where to send. It will check its gateway. Oh, my gateway is 192.168.1.1, meaning that if I want to go out or come in, I have to send my all the requests by default to 192.168.1.1, and 192.168.1.1 is something the IP address of your router. The request will come over here. Router will see that the request has come from 192.168.1.10, which is a private IP address. It will look up for its NAT table. It will find the entry that yes, the administrator has configured a NATing saying that if any request comes from 192.168.1.10 and want to go over the internet, translate it. Router will translate this IP address to 1.1.1.1 and it will send it over the internet. Till here it is clear. Now, when the router sends a request, now at that time it doesn't send the request like a dumb way. What it does is it will map the entry. It will map the entry, and how it maps? It says that the request was coming from 192.168.1.10, and I have forwarded this request to a server. Now that was 22.22.11.11, because even the server has a private IP address, but it will talk over the router. It will map the request that I have translated this address 192.168.1.10, 22.22.11.11. Now, this request has left the PC1 network. It has reached out of the router, and it is over the internet service provider network. Now, when it comes to this router, which has IP 22.20.11.11, again, over here also there will be netting done. And there are different types of netting, which we are going to learn. That netting can be source based netting, means that if this PC wants to send a request outside the network, you can do a netting. Similarly, if you have something, a server, which you have given a private IP address, and you are expecting that any request coming from outside to inside, any request coming from outside to inside should come to me, although I have a private IP address, and the request should come to me. There is one more netting, that is nothing but a destination based netting. So netting are of two types. Netting are of two types. It's not two types, more types are yet to come, but for now, it can be source based NAT, which is also called as dynamic NAT. and another NAT is destination based NAT, also known as static NAT. So we have learned this NAT, right? The PC want to send the traffic outside. So what you can do over here, you can have multiple IP addresses translated to one IP addresses, and that is nothing but a source based NAT or a dynamic NAT. In a similar fashion, you have something called one to one mapping. If the private IP address need to be converted to the public IP address need to be converted to private IP address. There is something called destination based NAT, and it's also called a static NAT. So this router will see that the traffic has come for the server, and I have an entry that 22.22.11.11 is mapped to this IP address. It will send the request over here. And again, when it sends, it note down the entry. This server will say that okay, this request has come from PC1, so it will read the request, and the server will say okay, I have to reply back. So when it replies back, what is the gateway? 192.168.20.1. It will reply back over here, and then this router will reply over the internet. It will come here, and then again the reply will come here to PC1. Is it clear? Any questions over here? Any questions? Daniel is asking, will one router use NAT to communicate with another router, or the source IP will use NAT through both routers address? See, NATing will be done over here, Daniel, as well as here. Now, let me tell you one thing. This PC, this network, this complete network which you are seeing, this network, over here there is a private IP address running. Now this PC wants to talk to any server over the internet. This cannot talk directly. We have discussed this. Why? Because this has a private IP address. Now, if this PC wants to reach outside, what it will do? It will reach to the router. Router will see that the IP address which has come is private IP and it is not routable over the internet. So this router has a functionality. If the administrator has configured netting, this will perform the netting. Meaning the private IP address will be converted to public IP address, that is 1.1.1.1, and the traffic will go over the internet. Over here, destination based NAT is again a very advanced topic. For now, I just simply said that whenever the public IP address is converted to private IP address, you can assume that this is a destination based NAT and the NATing will be done. Again, when the server responds back, it will reach to the gateway. This router will also see that the request is coming from private IP address. Okay, if it is coming from private IP address, so what I have to do is perform the NATing. It will do the NATing, but since the netting was already done over here, so it has an entry. It is the router knows that the request has come for request has already come, and I have already done the netting using the same details. It will reply back over here, and when the reply comes over here, this router also has an entry that I have done the netting for this 192.168.1.10. This session is open, so it will simply straight away send it to PC1. Is it clear, Daniel? Or you have any other questions? Please feel free to ask. And what about others? Everyone is understanding how the netting is performed? Now, if this is clear, there are no questions. We will take a break for 5 minutes, and then we will start with the classes of IP addresses. Very, very, very important topic, but no one should leave. Within 5 minutes, we'll come back. Be in the meeting. and we will start in 5 minutes. Before that, I will just answer the question of Yasin. Why is there a need for double net if already netting has done? Yeah, Yasin, let me tell you. Double net you are saying means that why the netting is done on this router, why the netting is done on this router, right? This is what you are asking, right? Okay. So, Yasin, 192.168.1.10, this is a different network. And this is a different network. What is happening over here? Will this router come to know what is happening over here? Now let's say, for example, I am at my home and I want to come out from my home. Where is the gate? I knew it, right? But at the same time, if you want to come out of your home, where is the gate? You know it. If I want to come to your home, if I want to come to your home, I moved out from my gate. It doesn't necessarily mean that I have reached your home. Now again, if I have to come to your home, I have to enter the gate, right? And I have to follow the procedure. What procedures you have at your home to enter, give the entrance to allow me to inside the home. So does it mean that if I have moved out of my home necessarily mean that I have reached to your home? That doesn't mean. In a similar way, this is a different network and this is a different network. And if I have moved out from here, it doesn't mean that I have a full privilege I can go anywhere. No. If my packet has moved from here, it has come till here. Now it is this router responsibility how it will route. Maybe if the netting is not configured, the traffic will drop over here itself. There will be no further action taken, and you will not reach to the specific destination. That is also possible. Clear? So let's take a break for 5 minutes and then we'll continue. We are going to move ahead with the discussion and we will be learning classes of IPv4 addresses. Do anyone remember? Yesterday I told you how many IP addresses, IPv4 addresses are there globally? Anyone remember? Yasin says 4.2 billion. Okay. So there are around 4.3 billion IPv4 addresses. Now, assume that managing all these IP addresses, 4.3 billion IPv4 addresses, managing these IP addresses without any classification. If you cannot classify, then managing this huge number, this 4.3 billion IPv4 addresses, is next to impossible. Now, when I'm saying that managing this 4.3 billion IPv4 addresses is next to example, let's take an example to understand this. Everyone has used a dictionary in their life, right? Everyone know what is dictionary. Or is there any smart personality in my class that he doesn't know or she doesn't know about the dictionary? Dictionary. Everyone knows, right? Now, if you have to find a word from a language dictionary, if you want to find a specific word from the language dictionary, how long it will take? Just think about it. The dictionaries are so huge, and finding a specific word is next to impossible, right? We're using this dictionary. But usually, within less than a 5 minutes, you can find any word from the dictionary. How? Because you are able to do this because the words in the dictionary are organized in alphabetical order. So straight away you go to the alphabetical order, and using that order, you can find the word within less than 5 minutes. Now let's say if you have to find the same word from the dictionary that is not in sequence, it's randomly arranged. Somewhere the letters are A, then in between you have V, then Z, X. It's not systematically arranged. It's not alphabetically arranged. It is not organized in alphabetical order. And if you have to find the same word from the dictionary that doesn't use any sequence or order to organize the words, It will take an eternity to find the word, right? It will take a huge time, or maybe before you find the word, you will just throw away the dictionary saying that it is totally useless, no use for me, I'm just wasting your time. So you will just throw away the dictionary. So if that dictionary, if the example which I'm giving you for the dictionary has assumed that 1 billion words without order, it can create so much disaster, it can be a troublemaker for you, you will never use those dictionary to find the word. Then imagine how painful it will be behind finding an IP address among this 4.3 billion IP addresses, amongst this 4.3 billion IP addresses. If you want to manage or find a specific IP address, how much difficult it will be. So for easier management, for easier management for easier management and assigning the IP addresses in an organized way. These IP addresses are organized in numeric order. These IP addresses are assigned in numeric order. Let's see how it is assigned. IPv4 addresses are assigned in numeric order. We will see how it is assigned. So your IPv4 addresses are classified into five classes. Into five classes. And these classes are nothing but a range of IP addresses, and it is called as class A, class B, class C, class D, and class E. These IP addresses are classified into five classes, starting with class A, class B, class C, class D, and class E. IP addresses are classified into these different classes: class A, class B, class C, class D, class E, depending upon their range and the usage. Now, let's discuss first class A. So, when you talk about class A IP address range, before this, I want to know that IP addresses we have learned it is a 32-bit address. It has four octets. Each octet has a number from 0 to 255. Everyone knows this. Yesterday we have discussed, right? So the IP address range of each octet can the number in each octet can be from 0 to 255, and how that number comes, that also we have justified in the theoretical lecture, and the practical also will justify. So now in class A, when you talk about, so any IP address from 1.0.0.0 to 127.255.255.255.255, this will fall in class A. This will fall in class A, 1.0.0.0 to 127.255.255.255. Sorry, not 127, it's 126. Or you can say that address range is from 1 to 126. Any IP address which starts from 1 and ends with 126, this will fall in class A. Now, each class has this specific IP addresses also. So, in class A, it has around 16 million IP addresses. Again, then you have class B. In class B, The IP address starts from 128.0.0.0 to 191.255.255.255. Any IP address that falls in this range is Class B IP address. It has around 65,000 IP addresses. Or else I have not explained you host and network concept. Just let me remove this. This is not, don't remember this for now because I have not explained you about host and network right. Okay. Then there is class C. Start with 192.168, sorry, 192.0.0.0 to 223.255.255.255. Then they have defined class D. The IP address range is from 224.0.0.0 to 239.255.255.255. Then they have class E. The IP range is from 240.0.0.0 to 255.255.255.255. So these are the classes defined so that you can manage the IP addresses very efficient way. Yes, Yasin, your question will be answered. You are asking that why it is not starting from 127. No problem. I will answer your query. Daniel is asking, is the range fixed? Yes, yes, it is fixed. It is defined as standard. It is a standard defined. So these are the classes. So class A range, any address which falls in this range 1.0.0.0 to 126.255.255.255 will be class A. Now I have not explained you subnetting. So if you are not able to understand, then just understand this, that any IP address you see starting from 1 and falls between 1 to 126 is nothing but the class A IP address. Similarly, the class B IP address range is there, class C IP address range is there, class D IP address range is there. These are the classes, and it's theoretical. It's a pure theory, but you have to just know this. In the interview for the freshers who are going, they might ask you that what are the classes, what is the purpose. So it is basically use and manage it very efficient way. And then you have the classes. Class A IP address range from 1 to 126, class B range from 128 to 191, class C range from 192 to 223, class D range from 224 to 239, class E range from 240 to 255. Now, till here, anyone has any questions? No questions. Okay. Now there are some special purpose IP addresses. There are some special purpose IP addresses. So what are the special purpose IP addresses? One is something called as loopback address. So Yasin was asking a question that why the class B address is not starting from 127, or where why the class A address is doesn't end on 127. Where is 127? He was very curious to know this. Where this 127 go? So this special IP addresses, in that there is the IP address 127.0.0.1. This is something the loopback address. Imran is a smart guy. He is saying loopback address. Oh yes, it is a loopback address. So what is the purpose of this loopback address? It is used to test the network connectivity within the same device that is sending the data. You have the network card, right? Everyone has a network card. Everyone knows what is network card, or is there anyone who don't know what is network card? If someone don't know what is network card, please feel free to ask me, and be bold enough to ask the questions. Don't think that if I am asking this question, what others will think. Remember that your career is in your hand, your future is in your hand. Don't think that what other thing. If you don't know, please feel free to ask. Yes, Ala, I will come to you. Private IPs and all, I will come after this. That topic will come. Don't worry. Now, everyone knows what is network card, right? Everyone has a network adapter in their PC. So I assume that everyone knows what is network card or Ethernet card. And okay, now open your command prompt, and if your network card is something very good condition, just say 127.0.0.1. On 127.0.0.1. What is ping command? Ping command is used to test the connectivity. Test the connectivity. Okay. And 127.0.0.1, I told you that it is used for some special purpose, and it is a loopback address 127.0.0.1. Now ping this IP address 127.0.0.1. You are getting a reply. So have you configured this IP address anywhere? 127.0.0.1. Yes, anyone? And everyone is getting the reply, right? Please confirm in the chat box if you have pinged this IP address and everyone is getting the reply. So this 127.0.0.1, the loopback address 127.0.0.1 is used to test the network connectivity within the same device on your own device. If this reply is coming, means your network adapter everything is working fine. It is something like sending the data, sending the request to yourself. And this 127.0.0.1 is often called as local host. This is also called as local host. So if someone asks you what is localhost, you can say that it's a loopback address 127.0.0.1, which is used to test the network connectivity within my device. That is, I can send the data to myself and test it. Is that clear? Now, in these classes also, you cannot use all these IP addresses. Huh? You cannot use all these IP addresses. Now, class A IP address, this is usable. You can use this. And you will find over the internet the IP addresses from this class. Similarly, class B IP addresses, these are usable. You can find this over the network. In class C, also you will find these IP addresses. They are usable. But this IP addresses, class D IP address, is something not used over the internet, but this is basically also known as multicast address. What it is known as? Multicast address. It falls under special purpose IP addresses, you can say. So what is multicast? I haven't explained you. So just remember that class D IP address is not used. It is used for special purpose, that is multicast address. What is multicasting? I will explain you. at the right time. But for now, it is not the right time to understand. You will not even understand what is multicast if I will explain you now. Moving on, this is multicast address. This is used for multicasting purpose from the 224.0.0.0 to 239.255.255.255. And the last class, class E, even this is not usable and this is not even available because this is something reserved for research and development. If there is any kind of research going on or any development is going on IPv4 addressing, the authority use this range for that purpose, and this is not for the general purpose. It is not generally available. So you can use class A, class B, and class C. Class D is meant for multicasting. Class E is something reserved for the research and development. This is reserved for the R&D purpose. And in between 127.0.0.1 is something a local host used for testing, self-testing. Is that clear? Any questions, any doubt on classes? Sohail is asking that why loopback IP address is chosen from class A. No, Sohail. It is not chosen from class A. You can see the range. Class A ranges from 1.0.0.0 to 126.255.255.255. And then class B starts from 128.0.0.0 to 191.255.255.255. Where 127 falls in class A? It doesn't fall in class A. Is it clear, Sohail? Okay. Before we conclude with the IP address topic, there is one thing remaining. Now, the question comes that we have understood the private IP address and public IP address, right? What is the purpose of private IP address? What is the purpose of public IP address? What is the purpose of private IP address? This we have understood. But how you will recognize what is the public IP address? What is the private IP address? We know that private IP addresses are the addresses that work with the local network for your home devices and all this. All thing we have already discussed sometime before, but it is very important to understand how you will identify, because again, if you cannot identify from these classes, see, classes starts from here to here, this if you cannot identify what is private, what is public, then there is no meaning of understanding all this thing. So there is a range. Within this range, no, the private IP addresses are segregated. The private IP addresses are segregated from this, and there is a specific range given for the private IP addresses. So we will learn over here private IP address range, and from every class, from every class, from class A, class B, class C, there will be a private IP address, there will be a public IP address. So when you talk about the private IP address in class A, in class A, private IP address will range from 10.0.0.0 to 10.255.255.255. So any address that falls in this range will be class A private IP address. Among the classes, see, just sometime before what we discussed over here, this is general. This is IPv4 address, and there are classes. The IPv4 address are divided into classes. That is class A, class B, class C, class D, class E. Now, from this, every class there will be private IP address and public IP address. So over here, when you see In class A, private IP address will be from 10.0.0.0 to 10.255.255.255. Similarly, from class B, in class B, private IP address will range from 172.16.0.0 to 172.16.255.255. From the class C itself, there will be a private IP address range. It is going to be 192.168.0.0 to 192.168.255.255. This is something which you have to memorize it. And this is again interview questions for the startups, for the starters who are just pass out. For them, it will be asked, what are the classes of IPv4 addresses? Then what is private IP? What is public IP? What is the range of private IP address? So the private IP address. If they ask what is a range of the classes class A, then you have to say this: class A, class B, class C, class D, class E. What is a purpose of loopback address? What is multicast address? And what is multicasting, that I will explain. Then you will understand that also. But for now, don't understand this because it is not the right time. The class E is something reserved for research and development for R&D purpose. Private IP address range is there. In class A, this is the private IP address. In class B, this is the range of private IP addresses. In class C, this is the range of private IP addresses. Is it clear? Any questions? Any doubt? Allah is asking, so local LAN should have from this private. Yes, Allah, right. Private IP address, local LAN. Your home appliances, your office PCs, servers, everything will have the IP address from this range, from the private range. Now, how you will decide that in your private network which IP scheme you will use, whether you will use class A, whether you will use class B or class C. Now, this question will be answered when you will learn subnetting. That when to use which kind of network. For now, just memorize this. This is the private IP addresses range. Is it clear? Now, what is the scope of this? Whenever you are connecting your home appliances, there will be computers, printers, and all. At that time, you will be using in your local area network. You will be using this IP addresses. So it is used to communicate your internal devices from one to another. As an administrator, you can configure it for your network. And there is a possibility that if you are using this IP scheme, there is a possibility I may also have the same scheme. That is possible because private IP addresses are not unique in nature. How to find your private IP address, that we have learned sometime before. Give ipconfig command and you will get the IP address of your machine. These are free of cost. You don't have to pay anything for this IP addresses. Now there are some differences between the public and private which you have already understood. Do you know want me to recall again? I don't think it is required. You already know what is the differences now. Allah is asking when IPv4 will officially end. Allah, it will never end. It is never going to end because 15 years back also I was listening that we need to go move on to IPv6. Today also we are listening the same thing and still people are using. I'm not saying that IPv6 is not in use. It is in use, but very limited. So IPv4 will officially, it will never end. Yasin is asking that which IP address will be used to cloud-based servers. So Yasin, again on the cloud, you will be using the private IP addresses for your servers, and of course you will be having a netting over there as well, where using that specific public IP addresses that it will be translated. So this idea about the cloud based, as I told you that we will having one dedicated lecture on the cloud technology. So at that time, I will give you deep insights on that as well. So for today's lecture, anyone has any questions? Yes. Yesterday, no one got the recording for some reason, but today you will get the recording for today's lecture as well as yesterday's lecture. Now, just click on Start button and type ncpa.cpl. Everyone type this ncpa.cpl. Click on Start button and type ncpa.cpl and hit enter. Everyone can see that this page is open for everyone. Network connection is open for everyone. Now, over here, you will be connected to your Wi-Fi network. Just click on that Wi-Fi network. Double click on over here. It will open the Wi-Fi status for you. Click on properties. It will open the new page for you. Over here, just scroll down a little. You will find see IPv4 address, IPv6 address. Just click on IPv4 address. Double click over here. If everyone has come to this, you will see in your computer also there are two options. Obtain obtain an IP address automatically, which means that dynamic IP. If you want, if you have a dynamic mechanism running in your network, if your router or any other network devices which is capable of providing the IP address over a DHCP, you can simply say obtain an IP address automatically, and you will get your device will get an IP address. But if it is not DSCP, if you haven't configured DSCP, you have a static network, you want to configure the static IP addresses, you will click this. You will configure your IP address, your subnet mask. What is subnet mask? Just for now, skip it. Default gateway you will configure, and just you will say OK. Now, close everything. Close everything. Again, double click over here on your Wi-Fi network. Double click. You can find detail button. Click on details. It will give you the detail of your network adapter, what IP address it has, and what default gateway it has. And more importantly, over here you will see DSCP enable. It says yes. Since it is a dynamic IP, it is saying DSCP enabled. Yes. Is it clear? You got an idea, right? How to see the IP addresses, how your computer also support a DSCP as well as static IP address. Everything is clear. Now, before we leave, I want you to do something before you come for the next class. Just a moment, I'm putting something on the chat box. I'm putting a link. Everyone got the link in the chat box? Okay, just go to this link. When you go to this link, which I have given in the chat box, you will find the option download Cisco Packet Tracer. Click on that. Let me show you. Click on this download Cisco Packet Tracer. It will open a new tab over here. And you can see that this option, Windows 64-bit and all, is not enabled. You cannot download this. You cannot click on this. For that, you know what you have to do? You have to log in. But since you are coming here for the first time, you will not have a login. So click on login button over here. And you can create your account. You can either say sign up, or you can use a Google account directly to sign up. If you're using Google, you can click over there, or else you can just fill up the form, click on continue, continue. Your account will be created. Once your account is created, you are logged in. This option will be enabled for you at that time. This option will be enabled for you. Simply download this and keep it ready with you. Sorry, not only download, install it. Once you download this package, Packet Tracer 8.2.2.2 Windows 64-bit, install it in your machine and keep it ready so that we can perform the practicals. Everyone got it? What need to be done? Or anyone has any questions, please ask. Allah is asking how can I know my NIC speed? That is a standard Allah. It can be 100 Mbps. It can no, sorry. Now no one gives 100 Mbps. It is 1G. So that I will show you. Not an issue. That I will show you. That we have something in the coming time. Maybe next to next lecture we will be having the components, how to look after the components, monitoring and all that we will see. So in today's class, we have completed this topic up to classes of IPv4 address. I was expecting we can start MAC address, but not an issue. We can start in the next lecture. So anyone has any questions, any doubt? And ensure that before you come to the next class, I want you all to have the packet tracer downloaded and installed in your machine. So that's all for today, and see you in the next class.